Welcome back, 7th grade Richmond Scholars. I'm Ms. Whitaker, and I'm excited to have you join me for another math lesson. This is week 5, day 5, and we will be discussing concepts related to SOL 7.10e. Let's get started. First, let's review the you-try questions from the previous lesson. At this time, you should check your answers. If you answered any of the questions incorrectly, take some time to see what you did differently. Lastly, you are going to correct your answers. Number 1. Kai is 7 years older than his sister Lou. Graph the relationship between Kai's age and Lou's age. So in the table, you're trying to figure out the relationship between Lou's age and Kai's age. Okay. So Lou's age would represent X, Kai's age will represent Y. So think to yourself, how can I go from 1 to 8, 2 to 9, 3 to 10? Each time you can add 7. 1 plus 7 will give you 8, 2 plus 7 will give you 9, 3 plus 7 will give you 10, and so on. So the additive relationship, or the relationship between X and Y, is additive each time you are adding 7. Okay? So write an equation that could be used to determine Kai's age, given Lou's age. Okay? So when we have a relationship that is additive, we use the equation y is equal to x plus b. Okay? B represents your y-intercept. Okay? So we figured out from the table our y-intercept is positive 7 or plus 7. Okay? So all you do is substitute b with the y-intercept, which is 7. So now the equation reads y is equal to x plus 7. 7 is your y-intercept. That is your starting point, okay? And X represents Lou's age, and Y represents Kai's age. Is this an additive or proportional relationship? This is an additive relationship. The same number is being added to X to get Y, okay? The line of the graph also does not go through the origin. Therefore, this relationship is additive. It is not proportional. And lastly, to graph the line that represents this relationship, you would just graph the ordered pairs created from the table. So once again, Lou's age represents X, Kai's age represents Y. So the ordered pair will be 1, 8, 2, 9, 3, 10. Okay, but our y-intercept is 7. Therefore, to graph the y-intercept, you find that number on the y-axis. So you will start at the origin and then go up to 7 to graph the y-intercept. From there, to graph 1, 8, start at the origin, move 1 place to the right, and up 8 units. To graph 2, 9, start at the origin, go 2 units to the right, and up 9 units. Okay? To graph 3, 10, start at the origin, move 3 places to the right, and up 10 units. To graph 4, 11, you will start at the origin, move 4 places right, and up 11 units. And then to graph 5, 12, start at the origin, move 5 places to the right, and up 12 units. After that, connect your dots and create your line. So this line here represents the relationship. The same relationship represented in the table and the equation. Number 2, Maria has 3 ceramic cats. She plans to buy some more. Write an equation that could represent the total number of cats given how many new cats. Create a table and graph. All right, so here it says she has 3 ceramic cats already, okay? She starts out with 3 ceramic cats. And she plans to buy some more. So therefore, we're going to be adding some cats to her collection, okay? So from there, we can say that 3 represents the y-intercept. This is where she is starting. Her starting point is 3. Okay, so it does not matter how many ceramic cats she has. Each time you will have to add 3 to account for the one she already. It does not matter how many cats she buys. You will have to add 3 to account for the number of cats she already had. Okay, so if 3 is our y-intercept, then we are going to replace b in the equation with 3. Okay, so we're using the equation y is equal to x plus b. We're going to replace b with 3. Okay, as I did here, y is equal to x plus 3. 3 is your y-intercept, so that's the starting point. X represents the new number of cats she's going to buy, and then y represents the total number of cats she will have. Okay, and here they gave you a table that was partially filled in. So if she started out with 0 cats, once again, our relationship between x and y is plus 3. Okay, so each time we would just add 3 to get y, but sometimes they did not give you x, and you can just work backwards and subtract 3 to figure out what x was. Okay, so 0 plus 3 gave you 3. Okay, 3 plus 3 will give you 6. However, this was blank, but you know you had 9 total cats, right? So therefore you will subtract 3, which means she bought 6 new cats plus the 3 she already had, which will give you 9. Okay, 8 plus 3 will give you 11. And here again, the x value was missing, so you can subtract 3 and get 10. So she has 10 new cats plus the 3 she already had, which will give you 13. Okay, is this an additive or proportional relationship? This relationship is additive. 3 is being added to x each time to get y. Okay, and we also know that it does not go through the line of the graph, does not go through the origin, therefore it's definitely not proportional. Okay, so the graph the line for this relationship, you would start by graphing the y-intercept. The y-intercept is 3, so you will start at the origin and you will find 3 on the y-axis. So 1, 2, 3 up, plot your point. Then from there, you can graph the points from your table. So the first order pair will be 0, 3, because x, new cats is x, y is total cats. So 0, 3, which we did, and that's the y-intercept, because the y-intercept is the y value when x is equal to 0. Okay, so the next point we will graph is 3, 6. So start at the origin, move to the right 3 units, and up 6 units. The next point we will graph is 6, 9. So move to the right 6 units and up 9 units. To plot 8, 11, start at the origin, move to the right 8 units and up 11 units. And I extended the graph to plot this last point, which is 10, 13, move 10 units to the right and up 13 units. So I just eyeballed it and added an extra unit. After that, grab your straight edge or your ruler, and you should have connected the dots to create the line. So today we will be learning how to make connections between and among representations of a proportional or additive relationship between two quantities using verbal descriptions, tables, equations, and graphs. Materials needed for today's lesson: you need pencil, paper, a calculator, and you also need a ruler or a straight edge. Make sure to write all of your notes, guided practice, and you try problems down in your notebook. If you have access to a printer, you can print out slides 9 through 12 in the PowerPoint and follow along with the video. So for your reference, I have vocabulary words for proportional and non-proportional relationships. So these are all the vocabulary words we've learned throughout SOL 7.10. Okay. So today we are going to, our goal is to make connections among and between proportional and additive relationships. So this table is going to help us compare and contrast additive and proportional relationships, okay? So you can represent proportional and additive relationships in 4 different forms: a table, a graph, equation, and words, okay? So we're going to discuss one at a time. So in a proportional relationship, the table will show a multiplicative relationship between the x and y values, okay? Which means in order to get, you must multiply x to get y, okay? So 2 is being multiplied by x each time to get y. So to get, I'm sorry, you must multiply by 2 in this specific table. You must multiply by 2. You must multiply x by 2 each time to get the corresponding y value, okay? 2 is the constant rate of change, which means 2 represents the, if you said slope, you are correct. Okay? In an additive relationship, okay, so when you're looking at a table of an additive relationship, the relationship between the x and y values would be some type of addition, or it might even look like subtraction. It's still additive, which means you're adding, but if the numbers are decreasing, that means you're adding a negative. So you can represent it as subtraction, okay? So in this particular table, 5 is being added to x each time to get y. Therefore, 5 represents your, if you said y-intercept, you are correct. Okay? So that's the difference between a proportional and additive relationship. Each time for a proportional relationship, you will multiply by a certain number, and then for additive relationship, the table of an additive relationship, you will add or subtract by a certain number. Okay, let's move on to graphs. So the graph of a proportional relationship will be, the line of a graph of a proportional relationship will be straight and go through the origin. Okay, so let's go ahead and graph the points from our table. So 2, 4. Start at the origin, move 2 units to the right, and up 4. Plot your point. 4, 8. Start at the origin, move 4 units to the right, and up 8. And plot your point. 6, 12. Start at the origin, move 6 units to the right, and up 12. And then 8, 16. Start at the origin, move 8 to the right, and up 16. Okay. Once you have done that, you're going to grab your straight edge or your ruler and connect the dots. If we extended this line, then this would go through the origin. However, there's another way to extend the line by graphing more points. We said the slope was 2, right? Therefore, you can turn that 2 into a fraction. Turn 2 into a fraction by placing it over 1, and 2 represents your change in y, 1 represents your change in x, which means your directions will be 2 up, 1 to the right. Because the 2 is positive, therefore you will go to the right. I'm sorry, the 2 is positive, therefore you will go up towards the positive numbers on the y-axis, and the 1 is positive, which represents a change in x, which means you will move to the right, towards the positive numbers on the x-axis. Okay? Therefore, to go underneath this point here, you will follow your directions the opposite way. Okay? So instead of going 2 up, 1 right, we will go 2 down, 1 left. Okay? Uh-oh. I'll move this line out the way so we can plot the points first. So you will go, alrighty. I had to move the line because it wasn't letting me. It didn't let me plot points while the line was there. So we're going to go in the opposite direction, go down, 2, 1 left. Go down, 2, 1 left. Okay? So from there, we can use our straight edge or our ruler to create our line, which does go through, the origin. Okay? So the graph of an additive relationship, the line of an additive relationship does not go through the origin. The y-intercept is where the line will cross the y-axis. Okay, so here we said our y-intercept was 5. Therefore, to plot 5, we go to the origin and we will find that number on the y-axis. Okay, so you're going to go up to the 5 and plot your point. From there, you can plot the points from our graph. So 1, 6. To plot that, you will start at the origin, move over 1 to the right, and then up 6. 3, 8. Start at the origin, move over to the 3, move right to the 3, or 3 units, and then up 8 units. Okay? 5, 10. Move right to 5, or move to the right 5 units, and up 10 units. And then lastly, 7, 12, you are going to move to the right 7 units and up 12 units. Plot your point. From there, you can use your straight edge. Okay, so that's the difference between the graph of a proportional relationship and an additive relationship. One, in a proportional relationship, it goes through the origin. The line will go through the origin. In an additive relationship, it will go through the y-intercept. It will not go through the origin. Okay. Now let's compare the equations. So the equation we use for a proportional relationship is y is equal to mx, where x is your independent variable or your input, and y represents the dependent variable or the output. Okay. M represents your slope, which is a constant rate of change. So we are actually going to write an equation that represents our relationship. We say our slope is 2. Therefore, you will substitute M, which is slope, with 2. So your equation is now 2 is equal to, I'm sorry, y is equal to 2x. Okay, the equation of an additive relationship is y is equal to x plus b. B represents your y-intercept. That is your starting point. X is still your independent variable or your input, and y is still your dependent variable or your output. But when we use the formula y is equal to x plus b, there is no number and there is no number beside the x. That means your slope is equal to 1. Okay, so we said our y-intercept was 5. Therefore, we are going to replace or substitute b with 5 and write the rest of the equation the same. So now the equation is y is equal to x plus 5. So you use different equations for proportional relationships and additive relationships. Okay, so lastly, we are going to compare verbal descriptions, what a verbal description looks like for a proportional relationship versus an additive relationship. Okay, so for a proportional relationship, you're going to look for words that represent slope or rate of change. So words like each, per, every, rate of change are some examples. So example is Lee is selling candy bars for a fundraiser. He earns $2 for each candy bar he sells. So that word each represents a rate of change or a slope keyword. Okay. So therefore, you know you're going to have a multiplicative relationship, or this relationship is proportional. Okay. So for additive relationship, when is the relationship is expressed using a verbal description, you're going to look for words that represent addition or subtraction. Okay. And when I say subtraction, we're still talking about an additive relationship, meaning you're adding, but that just means you're adding a negative. So instead of adding a negative, you just represent it as subtraction. Okay. So words, some examples are more, less, older, younger, drop, rise, things of that nature. So example is Brandy is 5 years older than her cousin. Okay. Which means you would keep adding 5 years to Brandy's cousin's age to figure out how old Brandy is. Okay. So let's move on to some guided practice. Here we have multiple representations of a function, which are still representative of a proportional relationship. Okay. It could be representative of an additive relationship, but don't worry about the word function. Function deals with inputs and outputs, which is similar to what we are doing. Okay, so they give us a verbal phrase or a verbal description, and we're going to come up with the other three representations. The snow is falling at a rate of 1/2 inch per hour. Okay, so from this verbal description, we are going to come up with an equation that represents the relationship. Okay, so you know that first of all, we're going to look for words that represent either a rate of change, or we're going to look for words that represent addition or subtraction. And here it says the snow is falling at a rate of 1/2 inch every hour. So therefore, this word is telling us that this phrase is telling us that this is a slope keyword. Okay, especially this word rate. Okay, so therefore this will represent a multiplicative relationship. So we will use the equation y is equal to mx. Okay, so how much is the snow falling per hour? It's falling 1/2 inch. So 1/2 is actually your slope. So you are going to substitute m in the equation for your slope. So y is equal to 1/2 x. Okay. From there, we can create a table to represent the relationship. Okay. So I know every hour is falling at a rate of 1 inch. I'm sorry, 1/2 inch. So I'm going to pick even numbers. So when I graph it, it will be meter. Okay. So we know snow is falling at a rate of 1/2 inch every hour. So therefore, we're going to take half, or we're going to multiply our number of hours by 1/2, which is the same as dividing by 2. Multiplying by 1/2 and dividing by 2 is the same thing. So I know half of 2 is 1, half of 4 is 2, half of 6 is 3, half of 8 is 4, and half of 10 is 5. Okay. From there, we're going to create a graph that represents the relationship. And if you want, you can label your graph, your x values, which will be your hours, and your y values, which represents the snowfall. You will label it hours and snowfall. Okay. So from there, we can graph. We can plot our points. So the first order pair would be 2, 1, x, y. So 2, 1. So start at the origin, move 2 to the right, and up 1. Plot your point. The next one is 4, 2. Move 1, 2, 3, 4 to the right, and up 2, and plot your point. The next order pair is 6, 3. So start at the origin, move 6, 1, 2, 3, 4, 5, 6 to the right, and up 1, 2, 3. Then 8, 4, start at the origin, move 1, 2, 3, 4, 5, 6, 7, 8 to the right, and up 1, 2, 3, 4. And lastly, the plot 10, 5, you are going to start back at the origin and move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right, and up 1, 2, 3, 4, 5. Okay? From there, grab your straight edge or your ruler, connect the dots, and graph your line. Okay, so this line does go through the origin, even though we don't have a point there. If you wanted to check to make sure it went through the origin, then you would take your slope, which is 1/2, and get your directions. Okay, so therefore, 1 represents your change in y is positive, so that means it will be 1 up. 2 represents your change in x. It is positive, therefore it will be 2 to the right. And if you were going in the opposite direction, because this was the last point we had, we will have to go underneath that. We will go in the opposite direction of 1 up, 2 right. So therefore we go 1 down, 2 left. So 1 down, 2 to the left. And it does go through the origin. This relationship represents a proportional relationship. So at this point, you are going to try some problems on your own. You have 2 problems to complete. They are similar to the problem we completed. Okay. So when you are done with these 2 problems, you are going to head over to Clever, log into Dreambox, and complete 2 Dreambox lessons. And remember, your you try answers will be displayed and discussed in tomorrow's lesson, or actually will be displayed and discussed in Monday's lesson. Okay, so that's all I have for today. I will see you guys for the next math lesson. Have a great weekend.